All right, in this video, we're going to be talking about, it's an activity that I usually do in class to introduce the logistic differential equation. And so I'm going to try to keep track of everything. Usually in class, I have like a lot of 8 people like doing it, checking it, double checking it, triple checking it. And it usually takes us like 2 or 3 runs to really get it to work anyway. But here's what we're going to do. So I set up a spreadsheet that I think will work. So we're going to do 9 rounds, try to. And what's going to happen is we have a pool of 28 people, right? And so let's say they're the last people on Earth, whatever. And one of them is going to get infected with something that I call vampire hand syndrome. I don't know what that is. It doesn't really matter. You just get it. And then here's what happens. Once you have it, if you bump into someone who doesn't have it, they get it. If you bump into someone who already has it, they don't get it again. So that's the premise. So somebody's walking around, they bump into a vampire, I guess, and they get vampire hand syndrome. So we need to first find the first person who has that happen to them. That person will become infected. And so here's how this works. Like if I go up here, and so if 13 gets infected, I'm going to delete 13 from the survivors, and they're going to immediately pop up in the infected. And so this is where it gets a little weird because I didn't have time to try to like write a program to do this. And also I don't think I even know how to. Let me just do it. I'm going to delete 13 and you're going to see a number is going to pop up here. It's going to be 13. A random number between 1 and 28 is going to pop up in the bumps. We'll talk about that in a second. So first, let me just delete 13. And you can see 13 showed up here because 13 is now infected. And then an 11 showed up in the bumps. So depending on how we want to do this, we probably want to like talk about who got infected. And then we'll talk about who the infected people bumped into. So what the bumps group is, 13 got infected and then bumped into 11. So now 11 is infected. So to deal with this, it's kind of a nightmare because every time I delete something here, so this number right now is 11, but watch, when I delete the 14, that number is going to change from 11 to something else. I mean, it might change back into 11, but it's a random number between 1 and 28. So now they're both 7. So this is actually a really interesting scenario. 13 got it first, bumped into 7. And then I just deleted 14. 14 also bumped into 7. So like this is what's going to happen. So I'm going to organize it. I'll explain it as I go. But if I put the 13 back, it disappears. If I put the 14 back, it disappears. So what I need to do is I need a random number to start with. So this is going to be the first person who has this thing. So equals a rand between, and then 1 and 28. So one of these 28 people is about to get this thing, and it's 15. So I'm going to go up here and delete 15. And also I'm going to say that in round 0, so like when it first breaks out, there's one person who has it. So I'm going to fill that in. And this is the thing we have to keep track of. How many in each round are infected? So 15 got infected. 15, I'm going to regenerate the number. So I mean, so 15 now is infected. Or she is walking around with all the 28 people that exist in this world. I'm going to generate a new random number. I just have to change this number and it'll happen. I couldn't find a keyboard shortcut. Maybe there is one. Somebody let me know. So I'm just going to regenerate it. And the 5 is probably going to change. Not necessarily, but this will be the person that number 15 bumps into. They bumped into 11. Okay, so now I'm going to delete 11. And here, so this is the first round, right? So initially there's one person who has it. And now that's like state 0, right? The first round, like let's say after the first week, they only bumped into 11. So now there are 2 people infected. This keeps track of that. There's 2 people infected. Now I'm going to regenerate just to see who they bumped into. So like I prefer to regenerate these. So I'm going to say, let's go with, I'll go back to 28. It doesn't matter what happens here. I'm just generating a number. And then because I'm afraid that I will change these numbers, what I'm going to do is copy them and I'm going to special paste them. So that's Control-Shift-V. So 14 and 27 are now infected also. So let me delete them. So 14 and 27. Okay, so now there are 4 total people infected. So now these 4 people, 14, 15, 27, and 11, They're walking around with all the people. They might bump into each other, but they're probably going to bump into some of the people who aren't infected. And when they bump into them, they'll get infected. So let's see what happens. So I'm going to generate a number. They're now walking around. So here, okay, these are the people they've bumped into. So let me just take these, because again, I'm afraid I will accidentally re-randomize. So 17. So I'm just going to go, I'm going like by column across just to try to keep my sanity. So 17, you're infected. 18, you're infected. This is weird. 19 is infected and 10 is infected. So now there's 8. So look at this. We're getting like exponential growth, right? 1 to 2 to 4 to 8. If each of these 8 people bumps into someone who's not infected in this round, there will be 16 people and it'll be actually exponential growth. But it's starting to get more likely that they'll bump into someone who's already infected and not reinfect them because you can't. So the next thing we're going to do is generate another random number. This is where I start getting confused and where it's helpful if there are other people here. All right, I'm generating a random number to see who these people bump into. And so these are the bumps. These are the ones they bumped into. I'm gonna copy this. I'm gonna paste it special over here. All right, and let's go through and see. So 26 is now infected. 10 is now infected, but 10 was infected, so that's not a new infection. 6 is infected. 5 is infected. 23 is infected. 27 would have been infected, but they already are, so not a new one. 13 is new. 20 is new. There we go. So at the end of that round, we only have 14. Exponential growth has kind of slowed down, right? It should have been 16 if it was truly exponential, but we're losing this pool of uninfected people. Now there's 4. Now half of the people are infected. So we're going to do it again. And this is where it's going to like start taking I don't actually know. I was going to say it's going to start taking longer, but there's like fewer to track. So the 14 people who are infected are the people here. They have now bumped into these people. So let me copy and paste special. And now we're going to track it. So 16 is now infected. And this is where it gets exciting. Like who's going to be the last? 22 is infected. 1 is infected. 7 is infected. Wow, 26 would have been, but they already were. 24, 23 would have been, but they were. 4, 16 is already done. 13 is already done. 24 is already done. 1 is already done. 12 is not, and 3. Okay, so now we're at 22 people. So if it were true exponential, I guess it would have been 28. It actually would have been 32 at this point. So like you can see it like tapering off. And also there aren't 32 people, so like not possible. All right, we're at 22. So it's getting close. So these 22 people are gonna mill around, probably gonna mostly bump into each other, but there's 8 uninfected people that they might bump into. That random 8 there was like coincidence. So let's generate, all right, and then let's paste special. I mean, I'm sure someone out there can do a better job of creating this spreadsheet. It took me that can't be right. Ah, crud. Oh wait, no, okay. So I accidentally didn't paste special, I just pasted, but I can still, I can save this because I can do Control-Shift-V and get that. That's the data because I had already copied it. Whew. Okay, so let's see. We got to run through these. So 18 is now infected, 13, 28 is new, 12. You know, now that I'm thinking about it, what I could have done is I could have done a conditional formatting thing where it would like tell me if somebody was like in this bunch, it would have highlighted it over here and I would have like immediately seen what to delete, but like whatever. 10, 20, 23, 13, 10, 26. You can see like they're just not hitting new people. 20, 21 is out, yes. 1, 20, 14. 3, 27, 5, 13, 24, 3, 20, and 8. Nice. All right, there's only 3 people left here. So 25 there. All right, now these 25 infected people are gonna walk around. They're gonna bump into people. And we're gonna see if they get any of these. So I can already see that 2 is gone. So I'm going to copy this and I'm going to paste it special. All right, so let's see. 4, 5, 9, 13. 9 is gone. Okay. I'm sorry, 4, 15, 9, 13. 16, 13, 17, 8, 3, 1, 20. Basically, I need 2 or 25. 25 and 2 are both in here. So 25 is gone and 2 is gone. Boom, boom. All right, that usually doesn't happen. So 28. All right, now, what does the data look like is the question that we want to ask. So I created a graph of this. This data might not be perfect. You can run this simulation again on your own if you want. I guess I'll like post a link to this in the description. Let's look at the graph. So in my experience, it usually takes around like 7 to 10 rounds to bump everybody out. It's always really exciting in class, like who's the last person standing. Let's look at the graph. I think this is pretty good data. Yeah. So if you look, it looks kind of like smooth and exponential. And then you hit a certain point and then it kind of goes less exponential, right? So we have like this increasing concave up and then it sort of switches and becomes still increasing, but kind of concave down. So this is a logistic curve. They're also called S curves. This activity pretty much always will generate it. You need kind of like 20 plus people involved. So what I'm doing is I'm just using 28, like this, in this year in particular, I have 14 students in my class. So if we were doing it live, what we would do is I would assign each person 2 numbers and they would have to try to keep track of that. And that like, you know, probably wouldn't go that great. Why is this not like formatted? 1, 2, 3, 4, 5. Did I forget? Or I did. Okay, so you don't need to watch this. I'm resetting this. So that's the activity. It's pretty cool. I do think maybe I'll try, if you are looking at it in the description, I'm gonna try to, oh no, I can't really do that because, well, I don't know. You might have to do it exactly the way that I did it. So I'm setting it up again. When you're done, you have to delete these. But that was like pretty good data. All right, so that's the idea. It's you get infected, you can infect new people, but you can't infect somebody who's already infected. See how it spreads. It's going to spread logistically. I will be back and we're going to talk about the math and the calculus behind this, which is all like pretty cool. So I will see you there.